Today, we are looking at something that could completely change how science gets done. We're talking about an entire science team made of AI. So let me just start with a huge question. We all know that science can be, a pretty slow and careful process. But what if it didn't have to be? What if we could put scientific discovery on hyperdrive and solve massive problems in a fraction of the time?
Well, a team over at Stanford University just built a new kind of lab to do exactly that. But this isn't your typical setup with beakers and lab coats. The twist here is that the scientists, well, they aren't human at all.
All right, so this is about a whole new kind of team designed from the ground up to smash through some of the biggest roadblocks in modern science. Here's the core problem they're trying to solve. You see, the best science, the real breakthroughs, they happen when you get experts from totally different fields to collaborate. But just try getting a biologist, a machine learning expert, and a chemist to all speak the same language on the same project. It's tough, it's slow, it's a huge bottleneck. The solution they came up with is something called agentic AI. Now, I want you to erase any idea of a simple chatbot from your mind. We're not just talking about an AI that waits for you to type a question. These are AI agents that can use software, pull data, and, this is the crucial part, talk to each other to solve problems as a team. And this team of agents forms what the researchers call the virtual lab. So let's meet the crew. Who exactly is on this all-AI science team? First up, you've got the AI Principal Investigator, or PI. The human researcher basically gives the PI the big picture mission. The PI then acts like a manager, figuring out who to hire for the job. In this case, it brought on an AI immunologist, an AI machine learning specialist, and an AI computational biologist. And my personal favorite, it also brought in the critic. Its only job is to poke holes in every idea. It's the ultimate devil's advocate, making sure the science is rock solid.
And the speed? The speed is just mind-blowing. The lead researcher, Dr. James Zhu, put it perfectly. By the time he's had his morning coffee, the AI team has already had hundreds of research discussions. They don't sleep, they don't take breaks, they just work at a scale that's impossible for us humans.
Okay, so you've got this super fast, super smart team assembled. Now it's time to give them their first real mission, and it's a big one. Their mission was to design a brand new therapeutic to take on the virus that causes COVID-19. But not just any version of the virus. They had to target the new, rapidly evolving variants. This is like trying to hit a moving target that's also constantly changing its shape. It's an incredibly hard problem. And right out of the gate, the AI team made a really smart strategic call, all on its own. Instead of going with traditional antibodies, which are big and complex, the team decided to focus on nanobodies. Why? Because the agents figured out that nanobodies are smaller, simpler, and way more stable. That makes them much, much easier for an AI to work with computationally. This wasn't a human decision, it was the lab's own first move. So how did they actually pull this off? Well, the AI team created this really slick three-step cycle of innovation to design and improve these nanobodies.
It's kind of like a supercharged design loop. Step 1, suggest. An AI called ESM, which thinks about proteins like we think about language, suggests thousands of tiny changes, mutations, to existing nanobodies. Step 2, predict. The famous AlphaFold then takes those suggestions and predicts the exact 3D shape they would form when they grab onto the virus. And finally, step 3, score. Another piece of software, Rosetta, scores how strong that grab or that bond would actually be. And they just ran this loop over and over, feeding the best designs back into the start, getting better and better with each round.
Now look, all of this sounds amazing on a computer screen, but here's the billion-dollar question. Does any of it actually work in the real world? It was time to take these digital designs and see if they could be made real. So after 4 full cycles of this process, the virtual lab handed over a list of its 92 best and most promising nanobody designs to the human researchers for real-world testing.
And the results were a huge success. The vast majority of the designs were actually stable, meaning they could be physically created without just falling apart. And even better, 2 of the designs showed really exciting new abilities to fight off some of the key recent COVID-19 variants. It worked! Let's just zoom in on one of the superstars from this experiment.
The original nanobody, this NB21, it could barely bind to the new JN.1 variant at all. But look at this. The new version designed by the AI showed a 4 times improvement in its binding strength. The AI team took something that was basically useless against this new variant and made it powerful.
Okay, so let's pull back and think about the big picture here. What does all of this really mean for the future of science? Because this isn't just an incremental improvement, it's a fundamental shift.
This chart right here, this says it all. The human researchers, they basically just set the initial goal and then validated the final results. That accounted for about 1.3% of the project's work. The other 98.7%, that was all the AI agents, the design, the analysis, even writing the code. Almost the whole shebang.
This is the key takeaway. We have to stop thinking of AI as just a fancy calculator or a better microscope. This project shows that AI can be a true research partner, one that can strategize, create, and collaborate to solve problems we give it. And that, of course, leaves us with one final, very exciting question. Now that this blueprint exists for an AI science team, a team that can turbocharge discovery, what massive, world-changing problems should we throw at it next? It's really something to think about.